Okay, so this is the second part of complex numbers, which are lesson 3.3. Okay, Dawson, can you get the door, please? I just want to remind you of some things. First of all, that I to the first power is I, and that is simplified, right? Remember that? I is I. Okay, I to the second power is a -1. Okay, I to the third power is a -I, and I to the fourth power is 1. Those four numbers repeat over and over and over. So that if I want to do, let's say, I to the 63, remember that I take 63 and I divide by 4. Remember this? Okay. So this is a remainder of 1, this is a remainder of 2, this is a remainder of 3, and this is a remainder of 0. Okay? So 4 goes into 63 one time, 15, and so this has a remainder of 3. This number does not matter. That does not matter. It has a remainder of 3, therefore I to the 63 power is a -I. Okay?
So will there ever be anything that has a remainder bigger than 4?
No, no, because it goes into 4, so, right? So, yeah, no. Now, one of the things you're gonna have to do with this is simplify things. So if I had 3i times 2i, let's say this is number 1, the directions say simplify, that this is 6i squared, and that is a -6. We do not consider I squared simplified. So if you have I squared on your as an answer on your test, that's wrong. Another thing that is considered not right is when we take two numbers that are negative and we're going to multiply them together, that we poke an I out first before we multiply them. Because if you multiply these two together, you're going to get a positive, and that's not truly the truth. So the first thing is we poke an I out of both of them. Do you see that? Because I is the square root of a -1. Remember that? And I didn't mention that, but remember, I is the square root of a -1. That's how we deal with it. Okay? So basically now we get I squared times the square root of what? 90? Is that true? What is I squared?
Yeah.
What is I squared? -1. So we have a negative square root of 90. Now we have to look at 90 and make sure there's nothing that goes into it. And there is. I believe 9 goes into it, right? So what we end up, we get a -3 square root of 10 from that. Okay? Now, this was simplified. We can also solve equations based on this. Okay? What if we had a 4x squared plus 100 equals 0? And this is how I started. You probably don't remember it the other day, but this is how I started. We created these numbers so that we could use them to solve equations. Okay? And so what we get is 4x squared equals a -100. You can see the 100 is negative when I move it to the other side. Jaws, you understand that? Mm-hmm. We divide by 4, and we get x squared equals a -25. In the past, we would say no solution, because x squared cannot equal a negative number. But now we can take the square root of a -25, we can poke an I out, and then we just have times the square root of 25, which is x equals 5i. Does that make sense to you? Okay, everyone.
Because I thought, I equals I, sorry.
Yeah.
I equals 1.
This is a pure imaginary number. It's called a pure imaginary number. But now I'm going to talk, and I talked a little bit about this last week, what a complex number is. A complex number is when we have a real part and an imaginary part. This is a real part, And that's a b, guys. This is an imaginary part.
That A plus BI.
Yep, a plus bi. Okay. Okay, and the other day I had, and this one's a little bit more complicated. But remember what I said, if two, I don't know if you remember this, but if I said if two complex numbers were equal, then the reals were equal and their imaginaries were equal. Do you remember that? I'm going to show you an example of this up here. Can I do that? Does that confuse any of you? If I can get all this in. Let's say I have 4b minus 5 plus parentheses a negative a minus 3i equals 7 minus 8i. Now this looks like a bunch of gibberish until you really look at it. This right here is the real part. I just underlined it, and this is the real part. This right here is the imaginary part, and this is the imaginary part. So basically, if this is true, then 4b minus 5 has to equal 7, and a negative a minus 3 equals a negative 8. Does that make sense to you?
Pretty
Okay.
easy to do it, but you'll get like that.
Yeah. So if you want to solve for b, you say 4b equals 12, and then b equals 3. Okay? And if you want to solve for this, a negative a equals, if I add 3 to both sides, I get a negative 5, and so a equals 5. Okay? Now there are more complicated ones in your assignment. I'm going to do 47 if that's okay.
Yeah.
It's an odd.
So
Or
are
are
we
we doing evens?
No, we're doing all of them. The problem with complex numbers is there's so many different examples of them. I'm going to move 47 down a little bit so I can get a little bit more room. Yeah, scary, isn't it? Let's say we have 2a minus 4b I plus a plus 5b equals 15 plus 58i. Okay?
What's that, 58?
Yeah, 58i. You'll notice that this is switched around. That this is the imaginary part and this is the real part. Did you notice that?
Yeah.
Okay, it's hard to catch at first. So, and this one's in the right order. Normally we have the real part first and then the imaginary. So what happens is the a plus 5b equals 15. Do you see that? So the second part of the first one equals the first part of the second one.
2A, isn't it?
2a minus 4b is right
Oh,
here.
shoot, I'm in.
Okay, so then notice that 2a minus 4b equals 58. Okay? Now, the reason I put them was like that is you have two variables that you have to solve for, and there's different ways to solve for them. We can use the graphing method, we can use substitution, we can use elimination. Remember that? I'm going to use elimination. I don't know if you remember this, but I'm going to multiply the top one by a negative 2 so I can cancel the a's. Right? So this is plus a negative. So I'm going to go a negative 2a plus negative 10b equals a negative 30. And then I have 2a plus a negative 4b equals 58. We good? Josh, you remember this?
Yeah.
Okay, Bo, we're going to add these two together. Remember that?
Mhm.
So the a's go to 0, and I get a negative 14b equals, and these are unlike, so I take the sign of the larger, which is 58, subtract, so 58 minus 30 is 28, and I divide by negative 14, and B equals a negative 2. That is correct. And now I can put this negative 2 back into this one, this one, this one, this one. Doesn't matter. I'm going to put it in the top one because it's the easiest to do. So I have, and I forget the negative 2. I'm just going to go A plus 5 times a negative 2, which is B, equals 15. So I have A plus a negative 10 equals 15. And if I subtract a negative 10 from both sides, that's the same as adding 10. What's that?
25.
What did I do wrong?
No, that's
Oh,
the answer.
Oh, A equals 25. Sorry about that. I didn't know if I... Okay, so there you have A and B. And you don't have to put them, you know, we used to put them as an ordered pair. It doesn't have to be an ordered pair because we're not graphing. Okay?
Which one would go first if we did that?
A. It's always in alphabetical
So
order.
what is that telling you?
It's telling you that the real part, that A has to be 25 and B has to be the negative 2 in order for this number to equal this number.
Was it like telling you everything on a graph? Like
No.
architecture or anything?
No. No. Okay? You okay, Greeley? Alright, alright. Okay.
So how are you able to graph it? Like, just
You don't graph complex numbers.
Okay.
Are you okay with that?
Yeah.
Yeah, okay, yeah, as long, yep, you don't graph them, nope, you just actually use the same method, but you don't graph them, okay? But you do add, subtract, multiply, and divide complex numbers, okay? So let's take a look at that, all right? So let's talk about addition and subtraction. Everybody loves these because it's just adding like terms. For example, I'm gonna go ahead and do subtraction because addition's a little simpler. What number am I on?
5.
We're on number 5. Okay, so let's say that I have a negative 3 plus 7i. Subtract 5 minus 4i. Does everybody see that? And I alluded to this the other day. Utan, when you subtract a complex number, you bring in, you subtract every member in the group. So I'm going to subtract both these numbers. Now for me, the easiest way to do is to change all subtraction to addition and multiply by a negative 1 in the second. So what I end up doing is I take a negative 3 plus 7i, and I go plus a negative 1 times 5 plus a negative 4i. Okay, what I do is I'm going to bring this negative 1 because it's going to change both signs in here when you subtract. You understand? So when I distribute that through, and I can pull the parentheses now, I get a negative 5 plus 4i. Because if I was to bring the subtraction in, it'd make this negative and this positive. So I don't end up subtracting, I end up multiplying, or excuse me, adding. Okay? So now I add real parts. A negative 3 and a negative 5 is a negative 8. And I add imaginary parts. 7i plus 4i is 11i. And it should always be written in the form a plus bi.
Oh, so that's the answer?
That is your answer.
You don't have to simplify?
Nope. That you can't simplify. You can't add them together. They're not like. Utan?
So you count it wrong if we had 11i minus 8?
Oh boy, that's a great question. No, I probably wouldn't count it wrong, but it's not written correctly. And it'll screw you up when we start talking fractions. Yeah. Have a nice day, huh? Okay. All right. Don't panic. Now, do you think you understand addition?
Yeah.
Yeah.
Okay. Addition, you just pull them. You just change all subtraction to addition and add like terms.
Yep.
Okay. All right. So how do you multiply them?
Yeah.
Just like same terms.
Foil.
It's like addition you.
Foil. Oh, yeah.
There you go.
Oh.
Foil.
Yes.
No, I heard you, Addie, but when everybody's yelling at me, I can't really acknowledge one person because then I'm acknowledging the pack. And that just, you know, as a rabbit being hunted by greyhounds, you just don't do that.
He just
Okay.
likes me better.
Yeah, that's true.
It's
Okay.
in bad taste.
So this is a 3i. So I change all subtraction to addition. You ready? So I'm going to take this first term times this first term, which is?
Negative 10.
It's It's 10.
Oh, I thought it was a 3.
Okay?
It is a 5.
I'm working on it. These pins are hard to write with, but okay. So that's first, and then I go outer. What's that?
59.
15i.
Is
Inner.
that 3i?
Yes. Negative 3i.
Negative 2y.
Negative 2i.
Plus I squared.
And then last but certainly not least is what?
Oh wait,
Negative 3i squared.
A negative 3i squared. The nice thing about foiling is it puts the like terms usually in the middle. So I have 10 plus 13i, is that right?
Yeah.
Oh, man. And then plus a negative 3, but what's I squared?
-1.
Negative 1. So now I have 10 plus 13i plus 3. And so I end up having 13 plus 13i. Does that make sense to you?
Yeah.
Okay. 7. Would you do this one? 2 plus 3i times 2 minus 3i. So if I multiply first terms together, I get 4. Outer is negative 6i. Inner
6i,
and last.
negative 9i squared.
Okay, do you notice what happens to these two terms? So I have 4 plus 4 times the negative, excuse me, 9 times the negative 1, which is
9.
negative 9 times that, right?
9, yeah.
So it'd be 9, be 13. Notice that I multiply two complex numbers together and I get a whole number, don't I?
Yes.
Okay, a real number, okay. Keep that in mind in a few minutes, okay? All right, so let's take a look at this. I want you to do 5 minus I quantity squared. You have to rewrite it as 5 minus I times the quantity 5 minus I. And then FOIL it. That's what it means. So what happens when we take 5 times 5?
25.
Okay, I'm changing this to plus and negative. So 5 times 5 is 25, and the outer is,
5 with a negative I, or 5 negative I.
so it'll be a negative 5i, isn't it? What's the inner?
-5i
And then the last?
Is negative I squared.
It's
Negative I squared, right? Oh, wait a minute.
I squared.
It's positive I squared, isn't it? Okay? So we get 25 plus a negative 10i plus, what do I do with the I squared?
1.
Negative 1. So my answer is 24.
But isn't it a positive I squared?
Yes, but then I squared is a negative 1, Bo. Right? If you simplify I squared, it's a negative 1.
Okay. Yeah.
Does that make sense?
So that positive sign in front of it doesn't mean anything then?
This means it's positive. No more than usual. Okay, we good?
Yeah.
Okay. Well, one of the last things we're going to talk about is division, and it's always the hardest. Okay? Let's say that we had 3 plus 2i over I, over 4i. Okay, whenever you have just a product in the denominator, we multiply the top and the bottom by I. Okay? Okay, now hold on a second. What are we doing here? I is what again? From way back in the beginning of the notes, what is I equal to? Square root of a negative 1.
Yeah.
So if you have an I in the denominator, it's not considered simplified. Doesn't matter if it's in the numerator, but if you have an I in the denominator, it's the square root of negative 1. That's not going to, remember we can't have a radical in the denominator? It's called rationalizing the denominator. So what we're doing here is rationalizing the denominator. Do you get that? So that's why I multiply by I. Now on the top, I have 3 plus 2i in parentheses times I. Notice that it gets distributed to both numbers. On the bottom, it is just 4i squared. Do you see that?
Yeah.
Okay. So on the top, I have, if I distribute the I through, I have 3i plus 2i squared over, remember the I squared Utan is a negative 1, right? So a negative 1 times 4 is a negative 4. We no longer have an I in the bottom. Okay? That's good. So on the top, we have 3i plus a negative 2 over a negative 4. Okay? Now here's the kicker. You do all that work, this is not considered simplified yet. Because remember, I told you that these have to be written in complex form. A plus bi. So the negative 2 over 4 has to go first, plus, and then 3i over a negative 4. Now watch what happens. I'm going to simplify this as just 1/2, plus I'm going to move the negative 2 up above so I see it, and I separate it from the I. This is written in complex form. A plus bi. Okay?
Should the half be negative?
No, because I have a negative over a negative, which is a positive.
Okay.
Okay? You got it? Okay, I'm going to erase because I need a... Yes?
Wait, so the, 3 wasn't, wait, never mind, I thought 3.
Okay. Now, that's if you're dividing just by a product of I. Okay? Hang with me here. I'm trying to get through this. But what if we have this? What number am I on? 10? Remember I told you there was a lot of examples? We have a problem if it's like this. Now we have not only a product, we have addition in the denominator. This is a full-blown complex number, okay? And you remember I told you when we were dividing, that I remember when we multiplied those two together and we came up with a real number? Our answer was like 13.
Yeah.
Okay. What happens was we multiplied by the opposite number, and this is called a conjugate. These are called conjugates. This and this. And they have the same real, they have the same imaginary, but they are opposite signs in between. If I multiply the bottom by this, then I have to multiply the top by this. So I end up foiling the top and the bottom. So let's start with the top. Before I put my division bar, I'm going to go ahead and just multiply this so that I get 10. Now, notice I leave room. I guess I can put my division bar. And then I go outer. I'm going to take 2 times the negative 6i, right? So I get a negative 12i, is that correct? And then I get 5 times I, which is 5i. And then I get I times a negative 6i, which is a negative 6i squared. Okay. Now, do you remember when I multiplied the two conjugates the last time? What happened to the middle terms? They canceled. Thank you, Carly. They canceled. So I don't even have to do the middle terms. I just do the first and the last. The middle terms will cancel if I do the conjugates. So I take 5 times 5, which is 25, and I take 6i plus a negative 6i, which is a negative 36i squared. Does everybody see that? The middle terms will cancel. You can go ahead and FOIL it all you want. If you need to FOIL it, the middle terms will cancel if you did it right. Really? You understand? Okay, on the top I have 10, plus, what, a negative 7i plus, that's negative 1, right? So plus a positive 6. Do we agree? On the bottom, I have 25 plus 36. No, because this is a negative 1, and a negative 1 times negative 36 is a positive 36. So on the top, I have 16 plus a negative 7i all over
61.
61. And I break it up. 16 over 61 plus a negative 7 over 61i. Whoops. Whoa, 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 Mr. Ellis, that's wrong.
So does I go in?
The I goes here. Sorry.
in the middle?
I knew you were gonna, the minute I put it there, I knew, and that's a problem. You don't want it in the denominator. It goes in the middle.
Where do you put it on? Is it wrong to put it up top?
No, I will accept that. I will not accept if you put it in the denominator. Okay? And there's a reason for that. We have a radical. Okay? If you look in your assignment at number 59,
Is our assignment big?
yep. Yeah, it is, Bo. The thing about complex number, there's so many different types of them. I sometimes wish they would make it two lessons, but they don't. I could almost, that's why I have 2 parts when I lecture on it. Okay, so I want to show you something. Here we do the radical. And you remember I told you that I always come behind it? Not when we have a radical. Why do we put the I in front of it?
So it doesn't look like it's under the radical.
That's right. Did you hear her?
No.
She said, so it doesn't look like it's underneath the radical. That is the only reason we put it in front. So what is the conjugate of the bottom?
2 subtract.
2 minus I cube, or, times square root.
That is correct. Here is the conjugate, and we multiply them. So, you ready? We're going to do the top. I'm going to try to do the top right here. So 2 times 2 is 4. I take 2 times this.
2I times the square root of,
This is negative.
or,
2i, keep going, you're right. Square root 3.
would it be,
Nope, it's negative.
yeah,
Yeah, that's what you're going to say?
Yeah.
Okay. And this is the same thing, right? Correct? So this would be a negative 2i squared root 3, correct? And then the last one is what?
Negative I squared.
I think if they're both negative, it's got to be positive, right?
I squared,
Times the square root of 9.
So negative. So is it just negative square root of 9?
Actually, it's negative 3 when I,
Oh.
yeah, but I'm not going to do that right now because that gets confusing. So what happens here? The middle terms cancel, right? So I take 2 times 2, which is 4, and I take this times this. This one's negative. So I have
I squared
negative I squared
times square root of 3.
square root of 9, isn't it? Okay. All right. Top, 4 plus a negative 2i square root of 3 plus, we said what? Negative 3. Bottom, 4 plus, this is 3, this is a negative of a negative. Now watch that. That's a negative of a negative 1, which is positive 1. So it's 3. Did everybody get that? This is a negative 1, and then you have a negative of a negative 1.
Okay, so how did you get rid of the 1? Like, so up top you have 2, yeah, right there. You
This one and
negative
this
2
one?
I, yeah, you have 2 of those, and then
Yeah, I messed up there. You called me on it, Bo. You're right. This should be what? Negative
4.
4. There you go. Yep. Thank you, Bo. So now I have 4 plus negative 3 is 1 plus a negative 4i square root 3 over 7. Ooh. Oh, man, did I mess that up? So I get 1/7 plus a negative 4i square root 3 over 7. That is nasty. And notice that I include the y in the I in the middle, otherwise if it was in the radical, it'd be wrong, okay? Questions? That's not easy, is it? Okay. I have one more, then I'm done. And the only reason I'm gonna do this one is because I've had questions on it in the past. I'm gonna do 57, but 56 is just like it.
67 on the assignment?
Yep. You have 1 plus I times 2 plus 3I times 4 minus 3I. Okay, there's 3 complex numbers, okay? So folks, what you're going to have to do is you're going to have to multiply 2 of them together, take that answer and multiply by the third. So you can multiply these 2 together and then multiply it by that. You can multiply these 2 together and multiply by this, or you can multiply the outside 2 and multiply it by the inside. Which do you want to do?
First two.
First 2?
and then the last one.
First 2. Alright, so we have 2 plus 3I plus 2I plus 3I squared. Is everybody good?
Yep.
Now, before you go multiplying it by this, please simplify it. Otherwise it gets really ugly. So we have 2 plus 5I plus negative 3. So I have a negative 1 plus 5I. Notice how it simplifies to a nice complex number. Now we can bring this down and multiply it by using FOIL again. Jaws, you understand that?
Yeah.
So we go a negative 4 plus positive 3I, is that correct?
Yeah.
Plus 20I plus a negative 15I squared. So, a negative 4 plus 23I plus 15 times a negative 1 is a positive 15. So I'm getting 11 plus 23I. Okay. All right. Your assignment will be page 176. I need one of you to write it up there. Page 176. It'd be 18 through 60. It is due Wednesday. Nope, Thursday. You have win time on Wednesday. Okay. You have a quiz on Friday. You have a quiz on Friday, and this is the last section on the quiz. So 3-1, 3-2. On Thursday, I'm going on to the next section. It will not be on this quiz. Okay? All right, so this is due when?
Thursday.
All right. All right.